U substitution. Recall when we were asked to find the derivative of a composite function. We had to utilize the chain rule to take the derivative correctly. U substitution is a similar tool used to find the antiderivative of more complex functions, and essentially the undo of the chain rule. Let's start with an example. Evaluate. Notice upon first glance this looks like a fairly complex integral. But if we let u equal 4x to the third plus 7, so everything under here, we can then find the differential du equals 12x squared dx. This allows us to rewrite the integral in terms of u to make the integration easier. So the integral of the third root of u du. Notice how much less intimidating this integral is. Now let's finish evaluating the integral. We have our integral here. We have u equals to 4x to the third plus 7. We have du equals 12x squared dx. The integral of the third root of u du equals 3/4 u to the 4/3 power plus c. And don't forget, substitute your expression back in for u. So we plug in this for u, and we get our answer. Here's a summary of our steps for u substitution. Number 1. Choose your value for u. How? The best advice is to look for an expression in the integral for which you also see that expression's derivative. Number 2. Find the differential. Take the derivative and solve for du. Number 3. Make the substitution into the original problem. 4. Integrate as usual. 5. Substitute back in for u. Here's some more tips for choosing your u. Do's. Good choices for u usually include an expression raised to a power, an expression in a denominator, an expression as an inside function of a composition. Don'ts would be avoid choosing a value for u which is too complex. At the same time, make sure it's not too simple. For example, don't let u equal x.